In this video, we are going to take a look at equations of lines and a few variables that are included about those, like we saw in direct variation. Specifically, we're going to look at slope, which we've already seen with direct variation, but also we're going to look at something called the y-intercept. And we'll be able to relate those to either a graph or the equation of any straight line. And then we'll take a look to see when we look at a graph or really an equation, whether or not two variables are in direct proportion to each other. Okay, so when you are taking a look at a direct variation, we saw that y varies directly as x, and there's a constant involved there. This type of an equation gives you a straight line, like this one. And specifically, this one also crosses at the origin, or it crosses at 0 on both axes. So this would be a direct variation. Now, not all lines cross right there at the 0. Some of them might cross like this one, down at -1, but they could cross anywhere. Let me just draw a quick line here. Right like that one. So this is just a different line. It could cross at 0 like that, or it could cross anywhere up there. If it crosses anywhere up there, then we include an additional variable in our equation known as the y-intercept. Not sure why they call it a b, but that's what we always use. So b would be the y-intercept. Now, when you look at the equation here, it looks similar to our direct variation. There's a y and there's an x, a y and an x. In front of this x, there's a k, but over this one, it's an m. Well, this m, and I think we talked about with variation too, but the m is the special letter that we use to indicate slope. So if I have an equation, I can graph that, as long as I know what the slope is and what the y-intercept is. Fairly easy to graph. Or if I have a line, I can determine what the equation is. All I have to do is find out where that line crosses this, the y-axis, and what its slope is. How much does it rise over how much does it run? Maybe let's try that. For example, this line right here. I want to know what the equation of that line is. Okay, we'll have to figure out two things. So we'll have to figure out the slope, and we have to figure out the y-intercept. Let's take a look at the slope. The slope, we've seen before, is equal to the rise of a graph over its run. Notice the line straight the whole time. If I'd have a curvy kind of line like that, I couldn't do that, like an inverse variation. I can't use this equation to define that because it's not straight. Has to be a straight line. So the rise over run. So I could pick any 2 points on there. Like I could pick this point, maybe, and well, let's pick this one. Sometimes it's nice to pick points that are quite a ways away from each other. And figure out how far you have to rise. So to rise, I'm at 2, so I have to go up 2. And then how far do you have to run? So I'd go up 2, and then I'd run 1, 2, 3, 4. So my slope for this line would be 2 over 4. I could also, of course, simplify that as a fraction to 1 over 2. So that is my slope. So if I'm taking a look at my equation up here, I know what my slope is. Y is equal to slope we found out to be a 2. So 2x plus, now I have to figure out where it crosses the y-axis. That's what B stands for. So here's the y-axis. This line crosses it right there at a positive 2. So the y-intercept, do I have that down below here? Yeah. The y-intercept is positive 2. So B is equal to 2. You could really write that point as 0, 2. But in the equation, what we're looking for is that number right there. So up here, my y-intercept is a positive 2. So this equation defines that line. Why don't you try one? Maybe press pause, see if you can write the equation for that line. and then press play and see if you get it right. Okay, let's go for the slope first. Here's a point. That's not right bang on. Here's another one. Let's keep going up a little bit. There's another one right there. They're quite a ways apart. Those are good ones to use. So the rise, I have to go up 1, 2, 3, 4, 5, 6. So I'm rising 6 over. Once I've gone up 6, I'm going over 2. So my slope is 6 over 2, or I can simplify that. So that's equal to 3 over 1, or just 3. So that's what my slope is equal to. So my equation up here, y is equal to 3x. Now I have to figure out where it crosses the y-axis. This is my y-axis. It crosses right there at a -2. So b is going to be a -2. Even though the point for that is 0, -2, that's the official way to say what the y-intercept is. But in our equation, all I want is that last number. So it'll be y equals 3x minus 2. That equation defines that line. All right, the last thing I wanted to look at here is just how you can determine whether something is actually in direct proportion to something else. An easy way to do is to see if there's a straight line. If you can't really tell whether it's a straight line, you can also look at the data and just compare and see if you can see consistency among the data. But let's plot a few points here and see if we can do that. This point here would be 0, minus 1. Here's another point, that would be 3 and 0. Where's another point? Right there. So that would be 6 and 1. Looks like those are all the points that I have. Okay, do you notice anything, a consistency among the data here? Like look at the x values, look at the y values. Maybe don't look as much at the relationship between these, but look at the relationship between these. When I take a look at the numbers here, I see that this one jumps by 3, and then this one jumps by another 3. Now, for every 3 that this one jumps, it looks like y only jumps 1. If you're down 1, you go to 0, you're up 1. To go from 0 to 1, it'd be another 1. So if I can see consistency among all the data like this, then I know it's a direct proportion. Just for interest's sake, see if you can figure out what the next 2 points would be. Press pause, try it. Okay, hopefully you said, well, this goes up by 3, this goes up by 3, got to go up by another 3, and another 3, and another 3, etc. This one goes up by 1, this one would go up by 1, go up by another 1, go up by another 1. Okay, so in this video we have taken just a quick look at lines and slope-intercept formulas. So we've seen that this equation here defines any line where m stands for the slope and b stands for the y-intercept. And you can take any equation like 2x plus 1 and you can graph that as long as you know what the y-intercept is, that's a 1, and what the slope is. So the slope is 2, the y-intercept is 1. So to graph that, I would just go up to 1, put a dot. My slope is 2. It's not a fraction, but I could write that as 2 over 1. So then I'd go up another 2 and over 1, and I'd find another point. Up another 2 over 1, I'd find another point. One thing you might be thinking of too, the other thing you could do is you could go down by 2, and then instead of going right this way, you go left. And that would be another point that would be on that line. So we looked at those, and then we saw that direct proportion is where the graph is a straight line, or when you look at the data, you can see consistency among the data. Okay, try some questions.